Welcome to the first lesson, Unit 1, Topic 1, AP Chemistry, the mole, molar mass, and Avogadro's number. Are you still studying in the same old way? Check here our new system. Just click the start timer. Your study system tracks the progress. You can know which skills you mastered, and you can get report. So each lesson is 45 minutes, and the time counts down. You can track how much time you studied, and you will check each skill you have mastered. So the progress will update as you check them. Don't forget, there is a visual progress. You will see how much from the unit or the topic you have finished, and you can track your study time, and you can save like video games. So you can save, and then you can remember where did you save the file, and then you can load anytime later from where you stopped. You don't have to start from the beginning every time. Then you can get a PDF report you can send to your parent or your teacher, and you can also find some study links here, practice material and periodic table. If you need some more help, you can just press email tutor and then you can get support from us. Ready? Click the start timer. So here I have started from some time. You can start from the beginning, and then this topic is almost 2% of the total exam of the AP Chemistry exam. This is 1.1. We know the mastery level from the beginning. So here I have finished all the checklists. That's why my mastery is 100%. You don't just check them, you check them after every one you have finished. So I'll see how we do this. So here my mastery level for this topic is still 0%. And as I check the ones that I am done, if I am done with the mole definitions and the molar mass calculations, then it will show that what is my mastery level right now. So today in our lesson, we'll know the mole concepts, the mass-mole relationships, particle counting, and formula applications. You can see also your progress dashboard here. What is your overall progress? What is your skills mastered? And what is the study time until now? The next checkpoint, remember, will be in the next October. We have our major examination to cover Unit 1. And essential study resources can be found here, the past paper questions, the cheat sheet, the definitions, and the periodic table also. You can save your progress here and then allow save. Then it will be saved here. And then you can use the files that you have downloaded so that you can find it and then you can load your progress. So here I have saved another progress and then I can load it. This is the button that can make the teacher report. And if you are lost, you can always email us by clicking at this button. This is how one mole of different substances look. So this is a mole of zinc, mole of nickel, mole of aluminum, sulfur, copper. Mostly you have heard this word in the school from your teacher, but what is actually the mole? A mole in chemistry is the amount of substance that's measured. So that's a unit that I will use to measure the amount of substance, know how many atoms, how many particles is in my substance. It's counting unit like dozen. So instead of saying dozen for 12, pair for 2, I'm having a bigger number, a very big number. It's a very, very big number. It's actually 6.022 times 10 to the power of 23 particles for every mole. So we call this number Avogadro's number. So we don't have to repeat the number every time and say 6.02 times 10 to the power of 23. I can just say Avogadro's number. Avogadro's number of what? Of anything, any type of particles. So since you say 1 dozen is equal to 12 things, so 1 mole is 6.022 times 10 to the power of 23 of anything. It can be an atom, a molecule. So a mole of atoms is this number of atoms. A mole of molecules is this number of molecules. A mole of sodium chloride is this number, big number of the formula units of this one. Even I can use it for things that's not chemistry. So 1 mole of apple is equal to 6.022 times 10 to the power of 23 apples, and so on. What about the molar mass? We have seen the mole. So this is a mole of zinc. So this means that this mole part contains a number of atoms of zinc that's equivalent to 6.02 times 10 to the power of 23 atoms of zinc, molecules of water here, zinc, nickel, aluminum, sulfur. So every one in this picture contains this big amount of atoms. If I measure the mass of this mole, of this big quantity, it will always give me something called molar mass. Always remember, molar mass means mass of what? Mass of 1 mole. So the molar mass of water is the mass of 1 mole of water. The molar mass of copper is the mass of 1 mole of copper. The molar mass of sulfur is the mass of 1 mole of sulfur, and so on. How can I find the molar mass of anything? I will just add the atomic masses in the formula. But where do I find the atomic masses? From the periodic table. Remember, you can always press here on the periodic table, and then you can get the periodic table open. So let's see the periodic table from our side. So this is our site special periodic table. I can look here at the carbon and see that its atomic mass is 12.01. And then for the hydrogen, it is 1.008. For the calcium, it's 40.08. And for the nitrogen, it's 14.01. Remember, this is the periodic table that you have to use. It comes with the exam. And you don't use any periodic table that doesn't match with the atomic numbers and atomic masses of the AP exam. Otherwise, the numbers will not be correct. So let's go back to where we wanted to know what is the atomic mass of carbon. So from the periodic table, we can see that it is 12.01. So the molar mass of carbon is 12.01. This is the mass in grams of 1 mole of this substance. So now you can link the mass in grams with the count. What is the name? The name is 1 mole. What is the count? 6.02 times 10 to the power of 23 atoms of carbon. And what is the mass of this one? Take the numbers that you saw on the periodic table and just put grams for it. So 12.01 grams for every mole. What is the meaning of mole? So this is a count. It is a big number. Everyone asks you the simplest definition of a mole is the count. So 1 mole means this count of atoms of carbon. So what is the mass of this count? Just go to the numbers that you saw in the periodic table, 12.01, and then add the letter G for it. It's in grams. What about water? If you want to do water, just look in the periodic table. I will see that hydrogen is 1.008. So let's have a look at hydrogen. It is 1.008 here. And then it's 2. So I multiply this by 2, and I have 1 oxygen only. In the periodic table, I can see that the oxygen is 16. So let's have a look. The oxygen is showing as 16 here. So I will add 2 of the hydrogens plus 1 of the oxygens to form 18.02. So now I can use the mole to link between things that I see and things that I don't see. So for example, this is the mass that I can see. This is the moles and particles. So the moles actually is a link. It's a link between these two together. Link between the mass and the particles, either atoms or molecules or ions. So I can say that the mass is equal to link with the moles by this rule. Let's have a look at this rule. And in this rule, we can use the triangle of the moles, which will help us a lot. Many students like to use the triangle because the triangle can help us easily find anything. So if I have masses, if I have moles, if I have molar mass, I can use the triangle easily. Let's have a look. Here there is the mass, here there is the moles, and here there is the molar mass. So we can just find any of the three if it is missing. So if this one is missing, the mass, I will just multiply these two together. So mass is equal to moles by molar mass. If the moles is missing, so we just divide this one by this one. So moles is equal to mass divided by the molar mass. If the molar mass is missing, so how do I get the molar mass? It's equal to the mass divided by the moles. So this one divided by this one. So mass is equal to this one multiplied this one. This is equal to this one over this one. And this is equal to this one over this one, and so on. So the mole triangle can help you find anything just by multiplication or division. And this is how to use it. Remember, top is equal to mass, moles by molar mass. Bottom left moles divide top by bottom right. And bottom right is equal to molar mass. Divide the mass by the bottom left, which is the moles. So if you have one of the three missing, you can get it from the other two by the conversion with the mole triangle. So remember that the molar mass can be worked out from the relative atomic or molecular or formula mass. And for ionic compounds, we never say the formula mass. What is the difference between these three? A very important question. The molar mass is the mass of 1 mole of anything. It can work with anything. It can work with atoms. It can work with anything. So it can work with atoms. It can work with molecules. It can work with ionic compounds. So I can use molar mass for anything. It's a mass of 1 mole. But if you want to talk about molecules, you can say either molar mass or molecular mass. So for covalent compounds, I can use molecular mass or molar mass. I can use any of these two. Again, covalent compound, you can use molecular mass because it's molecules, they are molecules, or molar mass. What about ionic compounds? In ionic compounds, never use the molecular mass. So ionic compounds either use the molar mass or the formula mass. Again, if you have ionic compound, use either formula mass or molar mass. If you have covalent compound, use molecular mass or molar mass. Never, because I see this mistake very many times. I see this many times. That people saying about ionic compounds, they say molecular mass. You cannot have a molecule in the ionic compound, as we see later in the next topics. Let's see our first question. Which statement best defines a mole? Is it the mass of one atom is 12 gram of 12 carbon 12 in grams? No. Is it exactly 6.022 10 to the power of 23 particles of a substance? Yes. This is the actual definition of a mole. How many water molecules are in 2 moles of H2O? So this is our triangle. What did the triangle say? The triangle said that the number of moles is equal to the mass divided by the molar mass. So what is required to find the moles? So I need to find this one. So divide the mass by the molar mass. The mass is equal to, oh, he wants to find the water molecules, sorry. So he wants to find the water molecules. If I want to find the number of water molecules in 2 moles, 1 mole will contain what? I need to find it in 2 moles. 1 mole will contain 6.02 times 10 to the power of 23. Why did you make the analysis like that? I made the analysis mole here and mole here so that they can cancel out. If you made the analysis in the opposite way, you can cancel it out. So the dimensional analysis has to always be set so that the moles cancel with the moles. But if you put the moles here at the top and put the Avogadro's number here, particles or molecules here at the bottom, you cannot cancel these two together, so it will be wrong. So you have to make the dimension analysis so that the mole is at the bottom, so it cancels with this. Okay, what is our conversion factor again? 1 mole has 6.02 times 10 to the power of 23. Mister, what do we choose? Is it atoms? Is it molecules? What do you want? You want molecules, so we have to make it in molecules. Here I need to change 2 moles, so this is 2 moles by my conversion factor. This will cancel with this, and then multiply 2 multiply 6.02. Let me use my calculator. I will say that 2 multiplied by, so 2 multiplied by 6.02 times 10 to the power of 23 will get me 1.20 times 10 to the power of 24, which is the second. I can always find that if the answers are correct or no by grading it. You'll see that I did not, these 2 are correct until now, but these 3 are not finished. I can say the molar mass of CO2 is closest to Y. Let's see CO2. So let's see, CO2 means 1 carbon atom and 2 oxygen atoms. There is a number here that's hiding. So 1 carbon and 2 oxygens. Let's have a look. The carbon from the periodic table is 12.01 and oxygen is 16. So I'll just add them together. So 12.01 times 16 multiplied by 2. If I do this in the calculator, I will get 44.01. And if I checked, I will find that this is the correct answer. Yes, it's the correct answer. How many moles are in 36 grams of H2O? So let me have a look. I want to find the moles. If I have the mass and the molar mass. The moles is equal to mass, which is 36.0, and the molar mass of water, we just calculated it as 18.02. Then it's roughly equal to 2 moles, which is the answer here. I'll just check again. This is my correct answer since it's green. If I made a wrong answer like that, it will come in red, which shows that it is wrong. You have 3.02, so you have 3.01 times 10 to the power of 21. Sodium ions, how many moles in that? So let me make the dimensional analysis. Again, I have 3.01 times 10 to the power of 23 multiplied by the conversion factor. Is the mole up or down? At this time, I have ions, so I have to put ions here at the bottom so they cancel out. 1 mole is 6.02 times 10 to the power of 23 of anything. But why did you choose ions? Because I have ions here. So I will cancel out ions with ions, and then I divide this number by 6.02. Let me do the calculation with my calculator. So I have that 3.01 times 10 to the power of 23 divided by 6.02. It's very clear that this is 0.5. So I got everything is right now. Now I can go back and mark this skill as known, because I can say freely that this is done. So this is what's good about this system, that I can always know what I have finished and what I did not finish. The biggest problem most students have is that I'm studying and I'm not very sure of myself. Did I finish? Is the topic done? Do I still need to answer more questions? So mole and definitions and Avogadro number is done. Molar mass is done also. I am 29% done until now. And see you in the next video where we'll continue.